So now let me just share my screen. We will quickly look at what is some minor changes as far as your limit state method is concerned. So this is the shear reinforcement for limit state method. Okay, so this we have already seen for working stress method. So nominal shear stress, I hope my screen is visible. Yes.
Yes, sir.
Okay, so here you can see tau v is given by vu upon bd. Okay, the only difference is may what you can see is here we are talking about limit state method, so we will consider factored shear force. So vu क्या हो जाएगा तुम्हारा factored shear force due to design loads. ठीक है, वर्किंग स्ट्रेस मेथड में हमने क्या देखा था, इट वाज ओनली v upon bd. So nominal shear stress is given by vu upon bd, where vu is nothing but your factored shear force. The rest of the thing remains the same. Next, coming to design shear strength of concrete. So design shear strength of concrete, as we have already discussed, it depends upon the percentage of tension reinforcement and the grade of concrete as given in table 19 of IS 456-2000. So these conditions we have already seen. Then if tau v is less than tau c, shear reinforcement is not required, but minimum shear reinforcement should be provided as per IS 456. So this you can find in clause number 26.5. So this is the condition for that. SV is equal to 0.87 Fy into ASV upon 0.4 B, where B is the width of the beam. ठीक है, और भी दो कंडीशन है, ये हमने न्यूमेरिकल्स में चेक किया था, 0.75 इंटू डी एंड 300. जो भी लीस्ट वैल्यू है दैट वी शुड कंसिडर फॉर आवर डिजाइन पर्पस. So where Fy is what? Fy is the characteristic strength of the shear reinforcement, which should never exceed 415. This we have seen in working stress method also. And ASV is nothing but the area of the stirrups, and SV is nothing but the spacing between the two stirrups. ठीक है, ये हो गया first condition. If tau v is less than tau c, then shear reinforcement is not required, but minimum shear reinforcement we have to provide. Now the second condition is if tau v is greater than tau c, then shear reinforcement is required. This we already know. Okay, one more thing we had discussed, that under no circumstances shall the value of tau v be more than tau c max, where tau c max is the maximum permissible shear stress, and this is given in page 73 table 20. Okay, I hope you remembered this. The value of tau v should never exceed tau c max. So I think I had given you the table of tau c max also. This is the table for tau c max. Okay, so this is M15, it is 2.5, M20 2.8, and so on till M40. So now can anyone tell me what if tau v is greater than tau c max? I had told you
Redesign.
redesign. Absolutely correct. So if tau v is greater than tau c max, you have to redesign, then revise the section. I hope this much is clear, everyone. So basic what we have seen, three terms. एक तो nominal shear stress, design shear strength, and these criterias, and tau c max. ठीक है, three terms we have seen so far. One is tau v, then tau c, and tau c max. Okay, so now tell me what is the difference between tau c and tau c max? Anyone? ठीक है, tau c और tau c max में क्या
Tauci,
डिफरेंस है?
Tauci max is permissible. Sure.
Tau c max is permissible. Yes, as the name suggests, it says that it is the maximum permissible value. Okay, but the actual difference, what is the actual difference between tau c and tau c max is, tau c is the resistance, the strength of the concrete. ठीक है, tau v क्या है तुम्हारा? Force है, it is the breaking force actually. What is tau v? Tau v is the breaking force, shear that is acting on the beam. And tau c क्या है? It is the saving force or the resistance force. So the resisting इसको tau c को we can also say it is the design shear strength of RCC we can say. ठीक है, design, if you say design shear strength of RCC, then also it will not be wrong. ठीक है, so we say that it is design shear strength of concrete, tau c. So it includes RCC, that is concrete also, and the longitudinal reinforcement also. Are you getting everyone? So this is the strength of concrete and the reinforcement. जो उतना उसका strength है resist करने का, that is tau c. Now tau c max is what? Tau c max includes everything. It includes concrete, longitudinal reinforcement, and also your stirrups. ये तीनों का जो भी कैपेसिटी है रेजिस्टेंस का, that is taken into consideration, and then the value of tau c max is assumed. Are you getting everyone? tau c और tau c max में difference क्या है? Tau c max takes into consideration the strength of the vertical stirrups also. ठीक है, उसके बाद जो भी वैल्यू है that is your tau c max. Hence we say that tau v should never exceed tau c max. Is this clear everyone?
Yes, sir.
Okay. And one more thing, ये जो table है this is given in IS code. And one more thing, WSM के लिए table अलग है और LSM के लिए अलग है. ठीक है, so if you remember working stress method, we had seen that after page 85 we had seen that section WSM. ठीक है, in LSM this you can find on page number 73. And one more thing, this जो tau c max का जो value है, this you can remember also. ठीक है, you can directly remember this value without actually referring the IS code. ठीक है, I'll tell you how. This value you can remember by just remembering one equation, that is 0.62 into under root fck. ठीक है, so if you remember this 0.62 into under root fck, so now for M15 grade of concrete, if you try to find out what is the value you are getting, you will get this value. ठीक है, approximately. ठीक है, I'm just giving you this how to actually remember this value of tau c max. ठीक है, you can make a note of this. This you will not find in IS code also, not in any textbook also. So I'm just saying this so that you remember this without actually referring the table. Is this clear everyone? Yes, am I audible?
Yes, sir.
Yes, what is the equation I just told you? I hope you have noted down that.
0.62 into under root FCK.
Yes. So now let us move on. The design of shear reinforcement. So I have already told you shear reinforcement we can provide in the form of vertical stirrups, bent up bars, and inclined stirrups. So vertical stirrups, let us see. The strength of the shear reinforcement is given by Vu minus tau CBD, where tau CBD is the strength of the section. Okay. So this consider a longitudinal profile of the beam and the cross section. I hope this is visible. So here I have drawn these vertical stirrups. ठीक है, ये तुम्हारे ये tension reinforcement है इधर, ये anchor bars, and these are the vertical stirrups, and this SV is nothing but the spacing. This is the spacing between the vertical stirrups. So spacing of the vertical stirrup is given by this equation 0.87 Fy into ASV into D upon VUS. Now can anyone tell me what was the equation for the spacing in working stress method? Yes, anyone? Okay, I'm just trying to compare it so that you remember what was the difference.
Sigma SV ASC sigma SV into ASV into D by VS.
Correct. Okay, I hope he was audible to everyone. it was sigma SV into ASV into D upon VS. ठीक है, so here I have just added VU. U means ultimate, ठीक है, factored load के लिए. So the only difference here is, ठीक है, I'll just show. The only difference here is this part, ठीक है, 0.87 FY. ठीक है, उधर क्या था, सिग्मा SV था, and here this is the additional term, 0.87 FY. ठीक है, so this will be easy for you to remember. Here the spacing is given by 0.87 FY into ASV into D upon VUS. That is the only difference. ठीक है, मिनिमम का क्राइटेरिया सेम है और ये बाकी के दो क्राइटेरिया भी सेम है. Is this clear everyone?
Yes, sir.
Okay, moving on to the next slide. The next is the vertical stirrups when group of bars are bent up at different cross section. ठीक है, तो फर्स्ट केस में क्या था, सिर्फ वर्टिकल स्टिरअप्स था. नाउ लेट अस कंसीडर दिस केस वेयर ग्रुप ऑफ बार्स आर बेंट अप एट डिफरेंट क्रॉस सेक्शन. इसका मतलब क्या है, इधर भी एक बार बेंड है और इधर भी एक बार बेंड है. सो नाउ ऑल ऑफ यू पे अटेंशन केयरफुली. सो कंसीडर दिस सेक्शन. Okay, so this is the section and I have this is the longitudinal profile and I have drawn three sections. I have cut three sections. This is X, this is Y, and this is Z. So this is the main longitudinal reinforcement. So here these are four bars. Okay, can you see, these are the four longitudinal bars and I'm going from right to left. ठीक है, मैं right से left आ रहा हूँ. So right, from right if I'm going, यहाँ पे 4 bars है but 2 bars are bent and they are taken upwards. So यहाँ पे कितने बचेंगे, 2 bars. Are you getting? And these are 2 bars. तो पहले 2 bars इधर bend हो गए and after that 4 bars tension reinforcement यहाँ पे है and then again 2 bars are bent. So how many bars are going into the support? Basically only 2 bars are going into the support. So now if we see, first let us see the X. ठीक है, सेक्शन X. सो सेक्शन X में देखो कितने बार्स है बॉटम में, देर आर 6 बार्स. ठीक है, यहाँ पे मैंने 4 मेंशन किया है और 2 बार्स बेंट है. सेकेंड लेयर पे है 2 बार्स. आर यू गेटिंग? सो 4 + 2 6 और टॉप में कितने हैं, सिर्फ एंकर बार्स है. नाउ इफ वी सी Y सेक्शन, ठीक है, Y सेक्शन जस्ट पे अटेंशन वेर इट इज कट. ये जो बार्स बेंड है उसके बाद ये जो बीच का पोर्शन है यहाँ पे कट किया हुआ है सेक्शन Y. सो सेक्शन Y में बॉटम में यू कैन सी 4 बार्स और टॉप में भी 4 बार्स है. एंड देन इफ यू सी द क्रॉस सेक्शन Z, सो बॉटम में कितने बचे, सिर्फ 2 बचे और टॉप में एक्चुअली जो बेंड होके गए तो 4 + 2 6. इज दिस क्लियर एवरीवन? यस.
Yes, sir.
Okay, so this was the case when actually the bars are bent at different cross section. So whenever bent up bars are provided, certain amount of shear is resisted by these bent up bars. However, the contribution towards the shear resistance shall not be more than half of the value of the total shear resistance required. So this we have already seen that the strength provided by the bent up bars should not be more than half of the total shear resistance. So now strength of the shear reinforcement, VUS is given by VU minus tau CBD, same, and shear strength of the bent up bars. Okay, so this we will denote it by dash, VUS dash. So this is given by 0.87 FY into ASV, A dash SV. A dash SV is nothing but the area of the bent up bars at a particular section into D, and this is the formula sin alpha plus cos alpha. अगर दो section पे two group of bars are bent at different cross section, then sin alpha plus cos alpha हो जाएगा upon SV dash. Is this clear? This is the spacing between the bent up bars. ये SV dash क्या है? Remember this. This is the spacing between the bent up bars. यहाँ पे मैंने mark किया है. Can you see? This point or this point is nothing but your SV dash. So this is the shear strength of the bent up bars in this case, where different terms you can see. ASV is the A dash SV is the total area of the bent up bars at a particular section. SV dash is the spacing between the bent up bars. Alpha is the angle of inclination, and this value should be generally greater than 45 degree, we assume, not less than 45. Okay, this condition you already know that VUS dash should be less than VUS by 2. If it is more than, then we will consider VUS dash is equal to VUS by 2. Is this clear, everyone?
Yes, sir.
Okay, moving on. So the actual strength of the shear reinforcement, ठीक है, actual strength क्या हो जाएगा, VUS double dash. So VUS minus जो bent up bar है उसका strength we will subtract. So then we will get the actual strength for which we will have to design the shear reinforcement. So shear reinforcement has to be calculated for actual shear strength VUS double dash. उसके लिए spacing का criteria क्या हो जाएगा, 0.87 fy into ASV into D upon VUS double dash. सेम थिंग है, बस यहाँ पे 0.87 fy is the change. So now remember, ये मैंने पहले भी बताया था, while calculating tau c, only those bars have to be considered which are going into the support. So now let us see vertical stirrups when group of bars are bent up at the same cross section. ठीक है, पहले था different cross section, ये same cross section है, मतलब एक ही बार bend किया हुआ है. So there are two sections x and y. So here bottom में 4 bars थे, 2 bars bend हो गए, तो यहाँ पे top में 4 bars आ गए, and bottom में remaining है 2. So in this case also it will be the same. Shear strength of the shear reinforcement क्या हो जाएगा, same रहेगा, Vu minus tau CBD. अभी shear strength of the bent up bars क्या रहेगा, it is 0.87 fy into ASV into sin alpha. ठीक है, so in this case it will only be sin alpha, और उसमें रहेगा sin alpha plus cos alpha, and ASV is the area of the bent up bars. So again same condition which we have discussed, और इसका shear reinforcement actual will be VUS minus VUS dash, or spacing will be the same. And last condition is inclined stirrups. ठीक है, so inclined stirrups में it is like this. Inclined stirrups are provided like this throughout the section of the beam. So in this, strength of the shear reinforcement again will be Vu minus tau CBD, and the spacing for this will be this 0.87 fy into ASV into D into sin alpha plus cos alpha upon VUS. ठीक है, ASV is the area of the stirrups which we are providing. So this was the basic theory of shear reinforcement as far as your limit state method is concerned. I hope this is clear to everyone. So in this, if anyone has any doubt, they can ask me right now, because after this we are going to start with the numericals. Yes, anyone?
Sir, the same procedure is on which page number in IS code?
Yes, so you can just, I have mentioned here the clauses. So if you go to clause 26, in clause 26 you will find these terms. Okay, so the table you can find on table 19. I think page 73 it is. So you won't find everything at the same place. Yes, limit state of collapse shear. Okay, so here you can see the nominal shear stress Vu upon Bd. Vu is the shear force due to design loads. Due to design loads means after applying the load factor. So this you can find in IS code on page number 72, limit state of collapse shear. ठीक है, design shear strength of concrete, table 19. Design of shear reinforcement vertical stirrups bent up bars. So table 19 you can find out for tau c. This is the table. Make a note of this. To find out the values of tau c, you will have to interpolate, use this table. Okay, so where you have to find out, you can just make a note. This is the tau c max, which I have already mentioned. This table is also given to you in IS code. And for vertical stirrups, this is the spacing. ठीक है, SV अगर इधर आ गया तो VUS डिनोमिनेटर में आ जाएगा. So that's what we have seen. And for inclined stirrups, ये भी अभी मैंने बताया. And this is for the single bar or the single group of parallel bars. ठीक है, तो IS कोड में एट डिफरेंट क्रॉस सेक्शन का नहीं दिया है, सिंगल ग्रुप का दिया है जो मैंने अभी बताया. So this is where you can find everything about the shear. Okay. ठीक है, so this page is important for you, page number 73, where you have to get the value of tau c from the table. Yes, is this clear everyone?
Yes, sir.
Okay, I hope the procedure remains the same. Okay, so the last time which we have done, the procedure to solve it, it will remain the same. The only difference you can see here is in the equation only. The rest, the procedure remains the same. So I think last 4 minutes are remaining in this session. So shall we start the numerical right now?
Yes, sir.
Okay, so what I'll do is I'll just give you the question. So in the meantime, just take down the question. Yes, all of you take down the question. Design the shear reinforcement for a beam of span 6 meters. Design the shear reinforcement for a beam of span 6 meters subjected to ultimate load of 60 kilonewton per meter. Subjected to ultimate load of 60 kilonewton per meter. Size of the beam is 230 by 800. Size of the beam is 230 by 800 and reinforcement is 4 bars of 20 mm dia.
So size of the beam is
Size of the beam is 230 by 800. Okay, size of the beam is
reinforced with
oh, reinforced with 4 bars of 20 dia. The reinforcement is 4 bars of 20 dia. So this is the question. You can start with the solution. We will continue in the next lecture.